Let's start the exam practice. Question 1, back titration, always comes up. You always need to practice it. Use 6 marks, the 6 minutes. It starts now. If you're rewatching the video, play it once you have tried it. Have passed. See how far you got, and remember that if you haven't finished, you always have a little bit more than 1 minute per mark, obviously, but also notice where maybe you took a little bit longer than you should. So it's very important that you do this type of analysis, okay? The correct answer is 9 carats. And in fact, you would find the percentage as 37.5%. Okay? So before we look at the solution, did you get it right? Raise your hand if you did. This mark scheme explains each where the marks are really distributed. So I'm just going to go through that, and then I would invite you to double check this mark scheme to look at the solution and if you actually got the calculation right. But notice that the first thing we need to do is to calculate the moles of silver chloride. Okay. Also by analyzing the data, it's really where you can start. Then you calculate the mass of silver. Okay, and the moles of copper. Okay, so okay, maybe it's not that clear, but anyway, if you calculate the mass of silver, then you can calculate the mass of copper as well. Here, I would invite you to look at the reaction, at the equation, because with back titration, remember that we always have one reaction taking place, and then there is the excess of that reaction is titrated in the second part of the reaction. Yeah, and that's where you would start the calculation. Okay, so we can calculate, in fact, notice here the moles of this sulfate, and then we can work backwards. Now, I know I'm not explaining it at all, but I want you to just think about the general steps so that then you can try it again and really work through the solutions. Remember, back titration, we always have an excessive initial amount of something. We have a reaction taking place, and then we have we have initial amount, we have a reaction taking place, and then there is an excess. The excess, yeah, it's is what you will calculate from the final titration. With this in mind, with these 3 steps in mind, reattempt this question and see if you got the right answer, which is 37.5. Otherwise, here is the very, very detailed mark scheme for you. If you don't get it right, then I am your 3rd step, okay? The question that I would like to try, and I'm sure then you will have enough time for this because this one is just 4 marks. It's what I mentioned at the beginning about linear equations. And this is a question that threw off a lot of students during an exam because it's like, oh, what is this? I've never seen it. Okay. So I really want you to apply your mathematical skills to figure out this question. Okay. So here I would give you 5 minutes because it's a explanation, 4 marks, 5 minutes. Let's start now. Okay, here, actually it was 4 marks, so I think it's okay to give at least an extra minute. Now, very important, what I want you to notice and revise is that the mathematical skills of the linear equation, which is mx plus c, okay? Very important. In fact, one of the marks is the link between this mx plus y plus c and the Gibbs free energy. Okay, do you notice the similarities? Well, we have the y-axis is our delta G. The x-axis is the temperature, so not the minus, but just the temperature. So what is everything else? Well, the delta H must be the intercept with the y-axis, because it's our C, and the delta S, yeah, it's going to be the gradient, but the minus delta S. So it would be our M. Okay, so the marks, P is delta H. The gradient is minus delta S. Sorry, that's also 1 mark. So 1 mark for this correlation, 1 mark for P, 1 mark for the delta S, and Q. Let's see if you figure out what that was. So Q, as you can see, is the temperature because it's the x-axis, but it's the temperature of the reaction for it to become feasible. The feasibility changes because as we go at a lower temperature, the delta G is negative. Reaction is feasible. At higher temperature, so up beyond that temperature, delta G, it's negative, it's positive. So it's a non-spontaneous reaction. So that's our 4th mark, is the temperature for the reaction to be feasible. Okay, we're ready for the next one. And without worrying too much about the time, we will do another question on thermodynamic. This should be a little bit faster because it's just a definition and completing the diagram. So let's do it. I really like this question because, well, it starts with a definition. And if you are my students, you know how with this specific topic, I highlight the definitions always, 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 because it doesn't only give you marks, but it also really helps you in working out the like equations, writing diagrams, or also with the calculation, okay? So 2 marks for enthalpy change of hydration is 1 mole of gaseous ions forming hydrated ions. So it's fundamental that you always mention the 1 mole, so 1 mole of gaseous ions to 1 mole of hydrated ions, okay? And the enthalpy definition always start the same, is the enthalpy change when, okay? So I'll show you the mark scheme as we go along, okay? So 2 marks for 1 mole of gaseous ion to 1 mole of aqueous ions. Now, this diagram, I like this question for this too, because these diagrams are always quite challenging. I mean, you're familiar with the Born-Haber cycle because you practice it so much and it's always the same layout, but you can apply the same concept to simple Hess cycles. And instead of cycle, we could write this enthalpy and these energy diagrams, okay? Or to like this example of the enthalpy of hydrations, okay? So this is where the marks are. Now, I want to compare it with your answer, okay? But I also want you to be flexible. I mean, the mark scheme, it allows many different ways, but also gives you mistakes for any other ways, okay? The important thing is that your directions make sense, and it's to find the connection between one reaction and another one, okay? So I would like you to try to compare these definitions with this diagram. Take a moment, maybe pause the video to really analyze it. I know it's really challenging when you're given just the definition and you don't really have the equations. So what you could do first is do all of the equations for each definition for each enthalpy change that you're given. And then I would highly suggest you to figure out how they're connected. Okay, because then you will notice that, well, if you write the equation for enthalpy change, lattice enthalpy, which is A, so gaseous ions to ionic lattice, you would also notice that the gaseous ions are also present in C and D, which is the enthalpy of hydration. And that's how we combine them together. We've put it in 2 steps because, like, if you remember the Born-Haber cycle, it's different steps. So you can add 1 step for the change in potassium, 1 step for the change of the sulfate ion. That's it. And then the last one will be the enthalpy change of solution. Of course, you need to remember what the enthalpy change of solution is, but then you can also just notice which of these reactions correspond to the reactants and the products of the enthalpy of solution, which is the last one that we have to find. And that's how you would find that the hours will go up from here. Okay, I hope it makes sense. I know it's really challenging, this type of diagram, but this same concept of writing down all of the equations and then work out the common reactants and common products for all of the reactions can be applied to both Haber cycle, but also, as I said, the easier enthalpy diagrams. So I hope you got it right, recording. Other diagrams that are actually allowed. Okay, for example, okay, here it says the mistakes. But for example, this is also like a different order. So it's also correct. There are many ways in the mark scheme. It is quite complex in terms of diagrams, but as long as your reactants and your products make sense and they're connected right, you will get the marks. If you still have any questions, just send me the picture and I can double check if we got all of them. Let's look at the entropy one. Remember that the entropy change. So here we're looking at the enthalpy at the change in solution, which is the solid lattice to the aqueous ions. And there are always two reasons why the entropy increases, yeah, which is change in state, so a more disordered state, or there are more particles formed. So in this case, the entropy it's positive because you start with one molecule and you end up with 3 molecules. The ions in a solid are not free to move, while the aqueous ions are free to move. So for this question, for 1 mark, the enthalpy increase, and then you can say either of one that I mentioned. I like the part 2 because it doesn't tell you exactly what equations to use and what to calculate, but it refers to the Gibbs free energy. And this is the correct value. And I hope you got it right. So when it says that, for example, a reaction takes place, and in this case, it dissolves. And then it's quite difficult because like, okay, but it's not talking about being spontaneous. Yeah. But it still infers these spontaneities. The reaction is spontaneous. You have to do the Gibbs free energy. So this is the correct answer, minus 43. It's the correct value for the enthalpy of, sorry, for the Gibbs free energy. Just to mix up your exam revision, now we're going to jump onto a question of organic chemistry, specifically organic analysis, which is the topic of focus of today. So I will open up these 2 parts of the questions and you can get started, okay? No worries about the timing so much. I just want you to apply what you've learned and, just mix up different topics. So just play when you're ready. So hydrogen NMR is not only this a more difficult type of analysis that we've done at the beginning of the lesson, but it can also be a little bit more straightforward, like working out just the chemical shift, the peak area, and the splitting pattern. Okay, and the important thing of this question that I liked is that it refers to the D2O. So remember that is a deuterated water. Okay, and what it does, it takes the place, deuterium takes the place of hydrogen in the molecules. But which hydrogen? It's called a labile hydrogen, which is the one that forms hydrogen bonds. That's why it will remove both the amine and the alkyl one. Okay. This means that we have just these 3 peaks because we have at the end just the CH3, CH, and CH2. So this is the relative peak area. And then the chemical shift, of course, in this case, that's where you can use the data sheet to help. Okay, so hopefully you all got it right. And then, well, the mass spectrum, notice that before I showed you just the mass to charge ratio and that's it, but it can be also a bit more difficult, the analysis. In fact, we need to be able to work out fragments as well in this one. So first peak is the molecular ion. The important thing and a mark that it's very easy to miss is the plus. Okay, so make sure you write down that it's an ion, otherwise you will lose the mark. Okay, easy to forget, please notice it. And then the fragments, well, how you work it out is a little bit trial and error. What can help is that you have the displayed formula and you think about where could this molecule be broken, and then you just find the mass the MR of each fragment until you get the one that corresponds to the peak, which is at 44. Okay, I hope you all got it right. Let's do a question on rate. Major topic AQA, you have it in paper 2. All the others, you have it in paper 1. And one important part of it is the Arrhenius equation. Okay, I know this is a topic that students don't like it from the beginning because it's sometimes a bit tricky. In terms of calculation, you have you have the exponential, you have to find the natural logarithm, then you have to apply it to a linear graph, so it can be a bit confusing. And you can also have some bit unfamiliar questions that look like this. And remember that the objective that I like to practice the most with you is the second objective, which is the demonstration, the application of knowledge, which is the difficult one because you're asked things that where you need to apply what you've learned. So think about it. This looks unfamiliar, but you know the Arrhenius equation, and you know to do calculations, like basic calculations. So this is what you will have to apply your knowledge to, if that makes sense. So don't be thrown off by an unfamiliar question, because this is exactly what they're testing. And with these 5 marks, I would like you to try that. So let's put the timer on this time, because I think it would be nice to put a bit more pressure. And 5 marks in a 6 minutes maximum, starting from now. If you're watching the video, pause and play once you're ready with the answer. Correct answer, 66.9 kilojoules per mole. So I hope you didn't feel the question was too unfamiliar, because I hope you could just rearrange. So it was just a bit of arrangement. If you got it wrong, let me know and I can go through the rearrangement. Okay, otherwise, I hope it was good. So I hope these values are clear. Remember to solve the brackets first so that you can make the rearrangement easier. It's not always that you need to rearrange the equations without numbers in. Sometimes it's easier to do this approach. Solve what you can solve, and then you can do the rearrangement. Okay. I know this is an unusual layout of a question, but I like it because it really, you have to analyze everything that is written so well. And then also it's, of course, a little bit of revision of transition metals colors, which I think it's really one of these topics that unfortunately does require memory. And I think this is a great chance to try it. And also, of course, some other reactions to remember. An unusual layout for exam questions, I know, but it's just for the sake of revision. So let's start this. It's 8 marks. I will just time it until let's see who finishes, okay, to understand a bit the timing of this. And if you're watching this video, pause now and play once you're ready. The timer starts now. I know there is so much going on in this question that it takes a while to analyze, but what I would suggest you to do when you have this type of comprehension, just have a look at the like an overview of the question, and some things will come up to you right away because they're a bit easier to remember, or you simply have more experience with it. For example, the one that I think is very straightforward is the silver chloride, because you know that that's just the test for chlorine, and that's formula of precipitate C. And then you can work, from this, you can think about, okay, what's the other reaction, and then combining them. And I know that it's extremely difficult to remember all of the colors of transition metals. So first of all, you have this solution, so maybe double check for a moment if you got them right or wrong. But remember, you have this paper, so I'd rather you go back to this and analyze each answer, okay? Because what I want you to tell you is that when you do transition metals, one of the best ways that you can write down the colors and the different reactions is using this type of flow chart. Okay, and I know it's not ideal to make notes at this time of the year because you should be doing exam practice, but transition metals are really difficult to remember. So why don't you look at the transition methods that you have to know, the different type of ligand substitution reactions or even precipitation reactions with the different colors, and try to construct a flowchart like this. Because by doing that, you would also be able to answer a question complicated as this one. Okay? So please go in your Google Classroom. The paper is right here, week 2, paper 2, with all of the solutions and a lot more questions that you can try. And don't be discouraged. I selected the most difficult questions of each topic that I have come across, okay, in order to give you the, these challenges and also to prepare you for the worst possible questions that come up in these papers. Now, analyze the mistakes that you've made so far, make a note of them. Before you ask me questions, look at the paper and make a note of, if there is a mistake that you didn't understand, if the mark scheme you didn't understand, okay? And once you've done that, please write me directly and I will help you personally.